So at least 6 of you guys emailed me about number 30. So I want to just make a quick video going over number 30. And before we start, if you did not check your solutions, right, which I hadn't posted them, I would really, really recommend checking your solutions, checking your work with the file that I just posted on Google Classroom. And then if you need to change anything, go ahead and unsubmit it, fix it, and turn it in by midnight tonight. I will not mark yesterday's homework, the more power practice rules homework, late if it's turned in by Friday, which is tonight, right at midnight. So as we kind of look at this question, one other thing that I really want to make sure that we're good with is we really, really need to be comfortable converting square root of x to a fractional exponent. I'm kind of going backwards, like if I had x to the 3 halves, changing that to square root of x cubed, or if I had x to the 7 halves, changing this to the square root of x to the 7th, and then, if it was instead x to the 2/7, this would become the 7th root of x squared. So if this is not something that you're comfortable with, just either go back to, we had a lesson on this in the review unit, or just go on YouTube and just search on YouTube, fractional exponents or fractional, radical exponent, something like that on YouTube, and just find a couple videos that you like to help you out with that. So that's a concept that we really, really, really need to understand well. So anytime in derivatives that we're seeing a radical, one of the first things that we're going to want to do is change that exponent to be a fractional exponent, because that's going to help us get it into polynomial form. So the first thing I'm going to do here is say, okay, we have f of x equals 7x plus 3x squared, all divided by 5x to the 1/2. Now, in my solutions, I actually did split this up, but you don't have to. So I'm going to kind of just show down here some questions that I hope we're comfortable with. If I had f of x equals x squared plus 2x, all divided by x, right? Hopefully we're all very comfortable saying, oh, there's an x in every single term, so let's cancel out an x. And so this becomes x plus 2, right? You also could have factored an x, like if you factored an x from the top. Right, we cancel it out. It's kind of the same thing. When we see it in every term, it's like factoring. So, another question we could have had would be f of x equals, say, x cubed plus x squared all over x to the 5th. And in this case, we can cancel out an x squared from every term, right? So we see an x everywhere, but the lowest exponent is squared. So I'm going to first cross out my x squared, and I like to make sure I put a 1 here. A lot of times students just forget about it. There needs to be a 1 there. Now, this is like the overall is 1. What I do is when I cancel out x squared, I kind of just cross out my exponent, or I put like -2 next to it. So I say, this is going to be -2. Some people will cross it out and just subtract 2, like say, oh, that's going to be 1. But I like to just kind of put -2 because that's what I'm doing. So this becomes x to the 1st plus 1 over x cubed. So this is something that we definitely should have been doing in Math 1, Math 2, especially in Math 3. So kind of coming back up here, it's the exact same concept. We have an x in every term, so we know we can cancel out an x. But the lowest exponent is actually the half exponent. So what I'm going to do here is I'm going to say, I'm going to cancel out my x to the half. That's going to just be completely canceled away. And then there was an imaginary 1 as that exponent. So we're going to subtract off 1/2, and we're going to subtract off 1/2, because that's the smallest exponent that we canceled out. And so now we get f of x equals 7x to the 1/2 power plus 3x to the 3/2 power, right? 2 minus 1/2 is 3/2, like 4 over 2 minus 1 over 2 is 3 over 2. So all divided by 5. And now for this step, this is where we would then split it. And we could have split it beforehand. It would have worked as well. So 7x to the 1/2 over 5 plus 3x to the 3/2 over 5. And you don't have to show this much work, but personally when I'm doing these, I like to, can I say 7/5 x to the half plus 3/5 x to the half. This kind of just helps me to see the 7/5 and the 3/f just as coefficients, right? They're going to just kind of hang out and be coefficients. But a lot of these steps you could skip if you were doing it on your own. So now f prime of x, right? We're going to take our exponent. We're taking the derivative now because now it's in polynomial form. So 1/2 times 7/5 gives 7/10 x to the 1/2, negative 1/2, sorry. We subtracted 1, right? And subtracting 1, it's kind of like taking the numerator and subtracting the denominator. 1 minus 2 is negative 1, but then make sure you still have over 2. And then plus, okay, 3/5 times 3/2, multiply the numerators, 3 times 3 is 9, multiply the denominators, 2 times 5 is 10, x to the 1/2, right? 3 minus 2 is 1, and still over 2. So now we can just rewrite this, right? F prime of x equals 7 over 10x to the 1/2 plus, and I'm going to just move this back into the numerator, 9x to the 1/2 over 10. Right, this went to the denominator because it was a negative exponent. And finally, we're just going to add back in our radicals. So 7 over 10 square root of x plus 9 square root of x over 10. And there's our answer. So again, there would have been a lot of different ways to do this. In my solutions, in my key, I actually showed splitting it first. So I kind of showed over here that first I changed radical x to x to the 1/2. Then I split it into 2, right? Wherever the positive sign is, we can split. If it's in the numerator, we can split the numerators. We leave the denominator the same. And then from there, what I did was that I just said, hey, this is like having the first power. So I made it 2 over 2, and this is the second power. I made it 4 over 2. And so I kind of said, okay, let's cancel out 1/2. So when we subtract 1/2, 2 over 2 minus 1 over 2 is 1/2. And then let's cancel out 1/2. 4 over 2 minus 1 over 2 is 3/2. And from there, everything else was the same. So I did it slightly different in that solution, but either way, it's the same. Just the main concept is that we can cancel out, just like, you know, if I had x plus x cubed over x, where we cancel out an x everywhere. Now, make sure there's a 1. 1 plus x squared. We can also cancel out a half. So if I had x to the half plus, say, even x to the 3/2 over x cubed, we can say, hey, let's cancel out a half everywhere. So this is going to become a 1, and then just minus a half and minus a half. And so we get 1 plus, now 3 over 2 minus 1 over 2 is 2 over 2. So just 2 over 2 is 1. Right? And then 3 minus 1/2 is x to the 5/2. So it's not going to come up too much in AP Calculus, but it is definitely something that we should be comfortable with mathematically. Let me know if you guys have any other questions on this particular question or any other questions. I know this is kind of a long explanation, but it's just something that I feel like is really important, so I wanted to spend a little bit of time on it.